Hello learners, welcome to our class. We are so delighted to have you. So before we start, click the subscription button and share our handle at Nakati254 to your friends and even this lesson widely. So let's start. Today we are handling a Form 4 topic, differentiation. Now, differentiation is part of the three topics that we call calculus. So we always have differentiation, area approximation, and integration. Now, differentiation is simply getting the gradient function of a curve. If you get the gradient function of a curve, you say you have differentiated. In Form 2, we always find the gradient of a line between 2 points. So if it is a line, the gradient will be constant. You take 2 points on that line, you find the gradient, it will be constant. But for a curve, the gradient cannot be constant. The gradient keeps on shifting, and therefore we use a gradient function to get the gradient of that curve at a specific point. NB. So gradient function is the same as derivative, derived function, and y prime. So e.g., y is equals to x raised to 2. So our dy dx will be, we take this power, we drop it here, or we multiply by whatever is in front here, which is 1. So we're going to have 2x, then we minus 1 from this power. So we're going to have 2 minus 1. So finally, you will have 2x, and that becomes your gradient function. So now, when the function is in this form, y is equals to x raised to n, our dy dx will be, we drop this n in front of x, or we multiply n with whatever is in front of x, which is 1. So you'll have n, then x, we minus 1 from that power, n minus 1. And that becomes your gradient function. When the function is in this form, y is equals to a x raised to n, then our dy dx will be, you take this power, you multiply by whatever is in front of x, so you are going to have an x, then we minus 1 from this power, so we're going to have n minus 1. NB. Now, change in y over change in x, this one is a gradient and it is always constant. But dy dx gives you what we call the gradient function. And this gradient function is the one that can help you to get the gradient of a curve at a specific point. Examples. Differentiate the following functions. Y is equals to 8x raised to 5. So we say our dy dx is equals to, you multiply this power with whatever is in front of x, which is 8. So this one will give you 40x. Then we minus 1 from this power. So you get this one is 4. So this is our A. Our B, we have y is equals to 1 over 8 x raised to 12. So if I'm told to differentiate this one, I will say dy dx will be equals to 1 over 8 times 12 x. Then we minus 1 from this power, so it will be 12 minus 1. So finally, you're going to have, so 4 goes here 2, 4 goes here 3. So we'll have 3 over 2 x raised to 11. C y is equals to negative 1 over 5 x raised to 10. Again, our dy dx will be equals to negative 1 over 5 times 10 x, then we minus 1 from this power, so it will be 10 minus 1. So you will have dy dx is equals to, so 5 here 1, 5 goes here 2. So you'll have negative 2x raised to 9. Let's continue with the example. We're told to find dy dx of the following equations. So A, I have y is equals to 2x cubed plus 3x squared plus 4x. Now, I'm supposed to differentiate this one. So I'll say dy dx is equals to, you come to this one, first one, you multiply this 3 by this power, so that one is 6x, then you minus 1 from the power, 2. Then you come to the next value, you do the same, 2 times 3, again you get it is 6x, you minus 1 from 2, you get 1, so that remains x, plus this one here is like there is 1 here, there is a 1 here, so 1 times 4, you get it's 4, then x, if you minus 1, this will be now 0. Now, according to laws of indices, anything raised to 0 is 1. So finally, my dy dx will be 6x squared plus 6x plus 4. Let's try another one. B, y is equals to 3x cubed plus 4x squared plus 2x plus 3. Now, if you're told to differentiate this function, you just say dy dx is equals to 3 times 3, you get 9, x, then you subtract 1 from this power, this one will be 2, plus 2 times 4 is 8, x, you subtract 1, you remain with 1, then plus, so this one is like there is a 1 here, so it is, when it is x, it means it is x raised to 1, so it is 1 times 2, which is 2x, so you minus 1, you get 0, plus this one, when it is 3, it means it was x raised to 0, like that. So 0 times 3 is 0, then if this is 0, then if you multiply anything by 0 is 0, so that one disappears like that, so it is plus 0, so it disappears. So meaning therefore our dy dx is simply 9x squared plus 8x plus 2. X raised to 0 is 1, so therefore you remain with 2. And b, when you differentiate a constant, it becomes a 0, and that's what we have seen here. This one was a constant. When you differentiate a constant, it becomes a 0. So you can say NB e.g. or i.e. if you're given to find, if you're told to find the dy dx of 6, simply 0. dy dx of 2 is 0. Let's continue with examples. So I'm going to differentiate the following. So y is equal to 2. So this is another example. We'll continue with the example. Y is equals to x squared plus x minus 2. So our dy dx will be, so if you take 2, you multiply by whatever is in front of x, which is 1, you get 2. Then you subtract 1, you get x. Then plus, so this one, if it is x, it means the power is 1. So 1 times whatever is in front is 1. Then it is x, 1 minus 1. So that 1 minus 1, so that will be 0. Then we have said if you differentiate a constant, it is 0. So finally you're going to have 2x plus 1, because this is 1 minus 1, which is 0. X raised to 0 is 1. So 1 times 1 is 1. Another one, we are told to differentiate y is equals to, so this is b, y is equals to x cubed plus x squared plus x over x. So now, if you're told to differentiate this one, first of all, simplify this function by dividing everything by x. So if you do that one, you're going to get y is equals to x cubed over x plus x squared over x plus x over x. So finally you're going to have y is equals to, so this one simplified according to laws of indices, so it's like 1 raised to 1 raised to 1. So this will be x, 3 minus 1 is 2 plus x squared, this is 2 minus 1, you get it is x raised to 1. Then this is like 1, so this one will cancel out, so we're going to remain with 1. So this one is the same as y is equals to x squared plus x plus 1. Then after getting that one, now is when you can differentiate. So and say, so we are having y is equals to x squared plus x plus 1. So our dy dx will be, so 2 times 1 is 2 x, then we minus 1 from this power, so it remains 1. Then this one, it is like x raised to 1, so 1 times whatever is in front here is 1. Then if you minus 1 from 1, you get 0, so x raised to 0 is 1, so you remain with 1. If you differentiate a constant, you get a 0, so this one becomes your gradient function. Now finally, we can differentiate this one. We are given s is equals to 2t cubed minus 3t squared plus 4t. So this one, we're going to say ds dt, because we don't have y and x now. So we have s and t. So solution will say ds dt is equals to 3 times 2, which is 6. And then t, we minus 1 from here, you get t squared, minus 3 times 2, which is 6. You minus 1 from 2, you get t, plus, so t, it is like t raised to 1, that is the power. So 1 times 4 is 4. Then you minus 1 from this, you get 0. So t raised to 0 is 1, so you remain with 4. And that becomes your gradient function. So that has been our introduction to differentiation. So I'll give you a small exercise to try, and let's see if you can score, and then we'll continue from there. So this is your exercise.